Question 1. Risk assessment procedures indicate that the enterprise network's access control logs must provide sufficient detail to satisfy potential regulatory audits concerning data access and user accountability. Considering the capabilities of Cisco ISE within an SDA environment, which logging configuration best ensures comprehensive auditability and compliance without introducing undue operational complexity. Option A. Configure ISE to log all authentication and authorization events, including detailed user identity, device information, and the specific network access policies applied. Option B. Configure ISE to log authentication and authorization events only for critical infrastructure devices and servers. Option C. Configure ISE to log only successful authentication events for all network access attempts. Option D. Configure ISE to disable logging for specific user groups deemed trusted to reduce log volume. Correct answer is A. Configure ISE to log all authentication and authorization events, including detailed user identity, device information, and the specific network access policies applied. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security and access control with the operational requirements of a dynamic and evolving business environment. The professional challenge lies in interpreting and applying the principles of Cisco's Software-Defined Access (SDA) and Identity Services Engine (ISE) within the context of a specific, albeit implied, regulatory framework that prioritizes data privacy and access logging. The system engineer must make a judgment call on the level of detail and granularity required for network access logging to satisfy compliance mandates without unduly burdening network resources or operational workflows. This requires a deep understanding of both the technical capabilities of SDA/ISE and the underlying compliance objectives. Correct approach analysis. The correct approach involves configuring ISE to log all authentication and authorization events, including detailed user identity, device information, and the specific network access policies applied. This aligns with best practices for auditability and compliance in regulated environments. By capturing comprehensive logs, the organization can demonstrate adherence to access control policies, investigate security incidents effectively, and provide evidence for regulatory audits. This level of detail ensures that the who, what, when, and where of network access are meticulously recorded, fulfilling the spirit and letter of many data protection and security regulations that mandate thorough logging for accountability. Incorrect approach is analysis. Logging only successful authentication events is insufficient because it fails to capture critical information about failed access attempts. These failures can indicate brute force attacks, misconfigurations, or unauthorized access attempts, all of which are vital for security monitoring and incident response. Failing to log device information or specific policy applications means that even if authentication is successful, the context of the access is lost, making it difficult to determine if a device was compliant or if the correct policy was enforced. This lack of detail hinders effective auditing and troubleshooting. Limiting logging to only critical infrastructure devices, while seemingly efficient, creates blind spots in the network. User and endpoint access to less critical resources is equally important for a complete security posture and compliance. If sensitive data resides on these less critical segments, or if compromised endpoints can pivot from them, the lack of logging becomes a significant vulnerability. Disabling logging for specific user groups, even if they are considered trusted, is a direct violation of the principle of least privilege and comprehensive auditability. Trust must be continuously verified, and all access, regardless of perceived user status, must be logged for accountability and to detect insider threats or compromised credentials. Professional reasoning. Professionals facing this decision should employ a risk-based approach. First, identify the specific regulatory or compliance requirements applicable to the organization's industry and data types. Second, understand the capabilities and limitations of the deployed SDA and ISE solutions. Third, assess the potential impact of different logging granularities on security, operational overhead, and storage requirements. The decision should prioritize fulfilling compliance mandates while maintaining a manageable operational burden. This involves a continuous cycle of assessment, implementation, and review, ensuring that logging configurations remain effective and aligned with evolving threats and regulations. Question 2. Consider a scenario where a business unit requests the integration of several new types of EOT devices into the enterprise network to support a critical operational process. The IT security team is concerned about the potential security implications of these devices, as they are from a third-party vendor and have limited security management capabilities. The network architecture utilizes Cisco SDA and SDWAN, with Cisco ISE managing endpoint access control. What is the most appropriate approach for the system engineer to ensure both operational continuity and robust security? Option A. Develop granular ISE policies that define specific access controls and network segmentation for the EOT devices based on a thorough risk assessment and the principle of least privilege, involving both the business unit and security teams in the validation process. Option B. Allow all new EOT devices to connect to the network with default ISE policies, assuming the vendor has implemented adequate security measures, and address any security incidents as they arise. Option C. Create broad ISE policies that grant the EOT devices access to the entire network to ensure they can communicate with all necessary resources, and rely on perimeter firewalls for overall network security. Option D. Immediately block all new EOT device types from connecting to the network until the vendor can provide comprehensive security certifications, and the IT security team can develop extensive, restrictive policies for all potential EOT threats. The correct answer is A. Develop granular ISE policies that define specific access controls and network segmentation for the EOT devices based on a thorough risk assessment and the principle of least privilege, involving both the business unit and security teams in the validation process. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a dynamic and evolving business environment. The core tension lies in ensuring that network access controls, particularly those managed by Cisco ISE, are not only effective but also adaptable to legitimate business needs without compromising security posture. The challenge is amplified by the potential for misconfigurations or overly restrictive policies to hinder productivity, leading to user frustration and potential workarounds that bypass security controls. Furthermore, the rapid pace of technological change and business expansion necessitates a proactive and iterative approach to policy management. Correct approach analysis. The correct approach emphasizes a structured, risk-based methodology for policy creation and modification. This aligns with best practices in network security and compliance, which mandate that security controls should be proportionate to the risks they are intended to mitigate. By involving stakeholders from IT, security, and relevant business units, the organization ensures that policies are not only technically sound, but also operationally relevant and aligned with business objectives. The iterative process of defining, testing, and refining policies in a controlled manner, coupled with continuous monitoring, minimizes the risk of unintended consequences and ensures that security measures remain effective and efficient. This approach directly supports the principles of least privilege and defense in depth, which are foundational to secure network architectures as outlined in Cisco's recommended practices for SDA and SDWAN deployments. Incorrect approaches analysis. Implementing a blanket denial of all new device types without a thorough risk assessment and policy definition is a failure to adhere to the principle of proportionality in security. This approach creates an unnecessary barrier to business operations and demonstrates a lack of understanding of the evolving needs of the enterprise. It can lead to shadow IT as users seek unauthorized means to connect necessary devices, thereby increasing the attack surface. Approving all new device types without any security vetting or policy enforcement is a direct contravention of fundamental security principles. This approach creates significant vulnerabilities by allowing potentially untrusted or misconfigured devices onto the network, undermining the entire security posture. It fails to implement necessary controls and risk mitigation strategies, leaving the network exposed to threats. Creating policies based solely on user requests without considering the security implications or the device's actual network requirements is irresponsible. This can lead to overly permissive policies that grant excessive access, increasing the risk of lateral movement for attackers. It neglects the critical step of understanding the device's role and the associated risks, potentially creating security gaps. Professional reasoning. professionals should adopt a decision-making framework that prioritizes a risk-based approach to network access control. This involves 1. Understanding the business context, clearly define the business need for the new device or access request. 2. Risk assessment, evaluate the potential security risks associated with the device and its intended use. 3. Policy definition, develop specific, granular policies that grant only the necessary access based on the risk assessment and business requirements. 4. Stakeholder collaboration, engage with relevant IT, security, and business unit representatives to ensure alignment and buy-in. 5. Testing and validation, implement and test policies in a controlled environment before full deployment. 6. Continuous monitoring and review, regularly audit and update policies to adapt to changing threats and business needs. Question 3. The investigation demonstrates that a Cisco SDWAN deployment is being considered for an enterprise that handles significant volumes of customer financial data. The primary goal is to improve network performance and reduce operational costs. However, the enterprise operates under a strict regulatory framework that mandates specific data protection measures for financial information transmitted across networks. Which of the following approaches best ensures compliance with these data protection regulations while achieving the SDWAN objectives? Option A. Prioritize the implementation of SDWAN features that offer the greatest performance gains and cost reductions, assuming that standard enterprise security protocols will inherently satisfy regulatory requirements. Option B. Implement the SDWAN solution with minimal configuration, changes to the existing security infrastructure, relying on the default security settings provided by the SDWAN vendor to meet compliance needs. Option C. Focus solely on the technical aspects of SDWAN connectivity and routing optimization, deferring any detailed examination of data privacy regulations until after the system is fully operational and has demonstrated its performance benefits. Option D. Conduct a comprehensive review of the chosen SDWAN solution's encryption capabilities, access control mechanisms, and data logging policies to ensure they align with the specific mandates of the financial data protection regulations before and during deployment. The correct answer is A. Prioritize the implementation of SDWAN features that offer the greatest performance gains and cost reductions, assuming that standard enterprise security protocols will inherently satisfy regulatory requirements. Explanation. The investigation demonstrates a scenario where a network engineer is tasked with implementing a Cisco SDWAN solution that must comply with specific data privacy regulations relevant to enterprise networks. The challenge lies in balancing the technical requirements of SDWAN for performance and agility with the stringent legal obligations concerning the handling and protection of sensitive enterprise data traversing the WAN. This requires a deep understanding of both the technology's capabilities and the applicable regulatory framework to ensure no data is inadvertently exposed or mishandled. The correct approach involves a thorough assessment of the SDWAN solution's data handling mechanisms against the specific requirements of the relevant data privacy regulations. This includes understanding how data is encrypted in transit, how access controls are enforced at the edge and within the overlay, and how any data that might be logged or monitored by the SDWAN controller or edge devices is anonymized or pseudonymized if it contains personal or sensitive information. Adhering to these regulations is not merely a technical best practice but a legal imperative. Failure to comply can result in significant fines, reputational damage, and loss of customer trust. The professional practice here is to proactively integrate regulatory compliance into the design and implementation phases, rather than treating it as an afterthought. An incorrect approach would be to prioritize only the performance and cost-saving aspects of SDWAN, without adequately considering the data privacy implications. For instance, implementing a solution that uses unencrypted tunnels for sensitive data, or one that logs personally identifiable information, PI, without proper consent or anonymization, would constitute a direct violation of data privacy laws. Another failure would be to assume that general network security measures are sufficient without verifying their alignment with specific data privacy mandates. This demonstrates a lack of due diligence and a failure to uphold professional responsibility in protecting sensitive enterprise data. Professionals should employ a decision-making framework that begins with identifying all applicable regulatory requirements for data privacy. This should be followed by a comprehensive risk assessment of the proposed SDWAN solution, specifically focusing on how data is processed, transmitted, and stored. The design should then incorporate technical controls that directly address these identified risks and regulatory requirements. Regular audits and validation of these controls against evolving regulations are crucial. Question 4. Upon reviewing the initial design for a new Cisco SD Access Fabric deployment, the system engineer is tasked with defining the security policy strategy. The organization has a diverse range of endpoints, from critical servers in the data center to user workstations and EOT devices. The engineer needs to determine the most effective and secure method for implementing segmentation within the fabric to protect sensitive data and limit the blast radius of potential security incidents, while also considering operational manageability. Option A. Deploy overly broad and static access control lists, ACL, across the entire SDA fabric to restrict traffic between all network segments, ensuring a baseline level of security for all devices. Option B. Immediately configure highly granular per-endpoint security policies for every single device connected to the SDA fabric to achieve maximum segmentation from day one. Option C. Rely solely on IP-based segmentation within the SDA fabric, without integrating with the organization's identity management system, to define access controls for different device types. Option D. Implement a phased approach to microsegmentation, starting with critical server segments and high-risk user groups, gradually expanding policy coverage as operational experience is gained and business needs are better understood. The correct answer is D. Implement a phased approach to microsegmentation, starting with critical server segments and high-risk user groups, gradually expanding policy coverage as operational experience is gained and business needs are better understood. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational demands of a dynamic and evolving business environment. The system engineer must make a critical decision regarding the implementation of security policies within a Cisco SD Access SDA fabric. The challenge lies in ensuring that the chosen approach aligns with both the technical capabilities of SDA and the organization's security posture, without introducing undue complexity or compromising user experience. The engineer must consider the implications of policy granularity and its impact on network management, troubleshooting, and compliance. Correct approach analysis. The correct approach involves a phased implementation of microsegmentation policies within the SDA fabric, starting with critical assets and high-risk user groups. This represents best professional practice because it allows for a controlled and iterative deployment of security controls. By prioritizing critical assets, the organization can immediately reduce its attack surface in the most vulnerable areas. This approach is also aligned with the principles of least privilege and defense in depth, which are fundamental to modern cybersecurity frameworks. Furthermore, a phased rollout minimizes disruption to end users and allows the IT team to gain experience and refine policies before broader deployment, reducing the risk of misconfigurations. This methodical approach ensures that security investments are strategically applied where they will have the greatest impact, while also allowing for continuous improvement and adaptation as the network and threat landscape evolve. Incorrect approaches analysis. Implementing overly broad and static access control lists, ACL, across the entire SDA fabric without leveraging the fabric's segmentation capabilities is a regulatory and ethical failure. This approach ignores the advanced security features of SDA, such as identity-based segmentation and policy enforcement at the edge, leading to a less secure and less manageable network. It also fails to adhere to the principle of least privilege by granting broader access than necessary, increasing the potential for lateral movement by attackers. Deploying highly granular per-endpoint policies for every single device from the outset, without a clear understanding of business criticality or user roles, is also professionally unacceptable. While granular segmentation is a goal, an immediate, all-encompassing deployment can lead to unmanageable complexity, significant operational overhead, and a high likelihood of misconfiguration errors that could inadvertently block legitimate traffic or create security gaps. This approach fails to demonstrate sound judgment in resource allocation and risk management, potentially violating operational efficiency and security best practices by attempting to achieve perfection prematurely. Failing to integrate the security policy implementation with the organization's existing identity management system, e.g., Active Directory, and instead relying solely on IP-based segmentation is a significant security and operational failure. This approach misses the core benefit of SDA, which is identity-driven policy. It leads to a less dynamic and less secure environment, as IP addresses can change, and it does not effectively enforce policies based on user roles or device trust. This failure to leverage integrated identity information represents a lapse in adhering to modern security principles and can lead to compliance issues if the organization has policies requiring role-based access control. Professional reasoning. Professionals should adopt a risk-based iterative decision-making framework. This involves 1. Understanding the business objectives and critical assets. 2. Assessing the current security posture and potential threats. 3. Evaluating the capabilities of the chosen technology, SDA in this case, and its alignment with security principles like least privilege and defense in depth. 4. Developing a phased implementation plan that prioritizes high-impact areas and allows for learning and adaptation. 5. Continuously monitoring and refining policies based on operational feedback and evolving threat intelligence. This structured approach ensures that security solutions are effective, efficient, and sustainable. Question 5. The efficiency study reveals that the current network segmentation strategy is proving inadequate in dynamically isolating sensitive application traffic from general user access, leading to increased security risks and operational overhead. Which of the following approaches best addresses this challenge within the context of Cisco SD access and Cisco ISE? Option A. Manually reconfigure VLAN and access control lists on core network devices to create static segmentation zones for different application types. Option B. Focus solely on optimizing the underlying network hardware performance without addressing the segmentation logic. Option C. Disable certain security features within Cisco ISE to reduce processing overhead and improve traffic flow between user segments. Option D. Implement granular security policies within Cisco ISE that define user and device context, and leverage the SD Access Fabric's capabilities to enforce these policies for dynamic traffic segmentation. Correct answer is D. Implement granular security policies within Cisco ISE that define user and device context, and leverage the SD Access Fabric's capabilities to enforce these policies for dynamic traffic segmentation. Explanation. The efficiency study reveals a significant bottleneck in the network's ability to dynamically segment traffic based on user roles and application criticality, directly impacting the effectiveness of security policies enforced by Cisco ISE. This scenario is professionally challenging because it requires balancing operational efficiency with robust security posture, a core tenet of enterprise network design. The challenge lies in identifying the most effective and compliant method to address the segmentation issue without introducing new vulnerabilities or violating established security frameworks. The correct approach represents best professional practice because it prioritizes a systematic, policy-driven, and compliant method for network segmentation. By leveraging Cisco ISE's policy enforcement capabilities in conjunction with the underlying network infrastructure, the solution directly addresses the identified efficiency and security gaps. This aligns with the principles of zero-trust architecture, where trust is never assumed and access is continuously verified. Furthermore, it adheres to best practices in network security by ensuring that segmentation is granular, context-aware, and dynamically enforced, thereby minimizing the attack surface and improving threat containment. An incorrect approach that focuses solely on network device configuration without considering the policy engine's role would be professionally unacceptable. This failure stems from a lack of holistic understanding of how Cisco ISE integrates with the network infrastructure for dynamic segmentation. It risks creating static, difficult-to-manage segmentation rules that are prone to misconfiguration and do not adapt to changing user or application needs, thereby failing to meet the dynamic segmentation requirements highlighted by the efficiency study. This approach could also lead to compliance issues if the segmentation does not align with regulatory requirements for data segregation or access control. Another incorrect approach that involves bypassing or simplifying security policies to improve performance would be a severe regulatory and ethical failure. This directly contradicts the purpose of implementing Cisco ISE and the principles of secure network design. Such an approach would expose the network to significant security risks, potentially leading to data breaches, unauthorized access, and noncompliance with industry regulations and organizational security mandates. It demonstrates a disregard for the fundamental responsibilities of a system engineer to maintain a secure and compliant network environment. Professionals should employ a decision-making framework that begins with a thorough understanding of the problem statement and its implications for security and efficiency. This involves analyzing the capabilities of the deployed technologies, Cisco ISE, SD Access Fabric, and how they can be leveraged to achieve the desired outcomes. The framework should then involve evaluating potential solutions against established security best practices, compliance requirements, and the specific goals outlined in the efficiency study. Prioritizing solutions that offer dynamic, policy-driven enforcement and minimize manual intervention is crucial for long-term effectiveness and maintainability. Question 6. Examination of the data shows a growing number of new EOT devices being introduced into the enterprise network, many of which lack robust built-in security features and require immediate access to specific network segments for data collection and reporting. The IT security team is concerned about the potential for these devices to introduce vulnerabilities. Which of the following approaches best balances security requirements with operational needs for these new EOT devices? Option A. Deny all access for new EOT devices until a comprehensive manual security audit and risk assessment is completed for each individual device, which can take several weeks. Option B. Deploy EOT devices with their default credentials and no specific access policies, assuming that network segmentation alone will provide adequate security. Option C. Grant all new EOT devices full network access immediately to avoid operational delays, relying solely on existing network-level firewalls for protection. Option D. Establish a dedicated, segmented network for EOT devices, implementing granular access policies based on device identity and function to grant only necessary permissions. The correct answer is D. Establish a dedicated, segmented network for EOT devices, implementing granular access policies based on device identity and function to grant only necessary permissions. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational demands of a dynamic and evolving business environment. The core tension lies between implementing strict access controls, as mandated by security best practices, and potential regulatory compliance. Though specific regulations are not cited here, the principle of least privilege in data protection is universally applicable, and ensuring that legitimate users and devices can access necessary resources without undue friction. The challenge is amplified by the rapid deployment of new EOT devices, which often have less mature security postures and may not easily integrate with traditional authentication mechanisms. A misstep here could lead to either significant security vulnerabilities or operational bottlenecks, impacting business productivity and potentially exposing sensitive data. Correct approach analysis. The correct approach involves a phased and risk-informed integration strategy for new EOT devices. This aligns with the principle of least privilege and defense in depth, fundamental to secure network design. By first establishing a dedicated, segmented network for EOT devices, the potential impact of a compromised EOT device is contained. Implementing granular policies based on device identity and function, rather than broad network access, ensures that each device has only the permissions necessary for its intended operation. This approach is best professional practice because it proactively mitigates risk, allows for targeted security controls, and facilitates easier troubleshooting and management. It also lays the groundwork for future compliance by demonstrating a structured and controlled approach to device onboarding and access management. Incorrect approach is analysis. Granting all new EOT devices full network access without prior assessment or segmentation is a significant regulatory and ethical failure. This violates the principle of least privilege, creating an open door for potential malware propagation or unauthorized data exfiltration from any compromised device. It demonstrates a lack of due diligence in risk assessment and control implementation, which could have severe consequences if a breach occurs. implementing a blanket denial of access for all new EOT devices until a lengthy, manual security audit is completed for each one is also professionally unacceptable. While security is paramount, this approach creates an operational bottleneck that can hinder business innovation and productivity. It fails to acknowledge the business need for agility and the potential for automated or semi-automated onboarding processes. This rigid stance can lead to workarounds that bypass security controls entirely, ultimately undermining the intended security posture. Deploying EOT devices with default credentials and no specific access policies, relying solely on network-level firewalls, is a critical security lapse. Default credentials are a well-known vulnerability, and relying solely on perimeter security is insufficient in modern threat landscapes. This approach fails to implement granular access controls at the application or resource level, leaving the network exposed to internal threats and lateral movement by attackers who gain initial access. Professional reasoning. Professionals should employ a risk-based decision-making framework. This involves 1. Understanding business requirements. What are the operational needs driving the deployment of these EOT devices? 2. Threat modeling. What are the potential threats to the network and data posed by these devices? 3. Risk assessment. What is the likelihood and impact of these threats? 4. Control selection. Based on the risk assessment, what security controls are most effective and proportionate? This includes considering segmentation, identity-based access control, and policy enforcement. 5. Phased implementation. Deploying new technologies in stages, starting with controlled environments, allows for testing and refinement before full rollout. 6. Continuous monitoring and improvement. Regularly reviewing security logs, access patterns, and device health to adapt to evolving threats and operational changes. This structured approach ensures that security measures are not only effective, but also practical and aligned with business objectives, while adhering to best practices for network security and data protection. Question 7. Performance analysis shows a significant increase in latency on the core network segment following the recent implementation of new CoS policies designed to prioritize real-time traffic. While the latency increase is within acceptable operational thresholds, there are concerns that the new CoS configuration might inadvertently relax certain security segmentation rules applied via Cisco ISE, potentially exposing sensitive user groups to unauthorized network access. What is the most appropriate next step to address this situation? Option A. Conduct a thorough security audit of the network segments affected by the CoS policy changes, specifically verifying ISE policy enforcement and access controls for all user groups, and develop a detailed impact report before proceeding with any further network modifications. Option B. Inform management about the latency increase and request immediate approval to proceed with a broader network refresh project that will address both performance and security concerns holistically. Option C. Focus solely on further optimizing the CoS configuration to reduce latency to its absolute minimum, assuming that the security implications are negligible given the operational thresholds are still met. Option D. Immediately revert the CoS policy changes to their previous state to eliminate the latency issue, and then reevaluate the CoS implementation in a separate, isolated lab environment without involving security considerations. The correct answer is A. Conduct a thorough security audit of the network segments affected by the CoS policy changes, specifically verifying ISE policy enforcement and access controls for all user groups, and develop a detailed impact report before proceeding with any further network modifications. Explanation. This scenario presents a professional challenge due to the inherent tension between optimizing network performance and adhering to the strict regulatory framework governing data handling and network security within the Cisco Enterprise Network's SDA, SDWAN, and ISE ecosystem. The challenge lies in accurately assessing the impact of a proposed network change on critical business operations and sensitive data, ensuring that any modifications do not inadvertently create vulnerabilities or violate compliance mandates. The regulatory framework for this exam, implicitly US-based given Cisco's primary market and common exam syllabi, would typically involve adherence to standards like NIST, HIPAA, if healthcare data is involved, PCI DSS, if payment card data is involved, and general data privacy regulations such as CCPA. The core professional responsibility is to proactively identify and mitigate risks before they materialize. The correct approach represents best professional practice because it prioritizes a comprehensive and systematic impact assessment. This involves a multifaceted evaluation that considers not only technical performance metrics, but also security implications, compliance requirements, and business continuity. By engaging stakeholders, documenting findings, and developing a rollback plan, the engineer demonstrates due diligence and a commitment to maintaining a secure and compliant network environment. This aligns with the ethical obligations of an IT professional to protect organizational assets and user data, and the regulatory imperative to maintain systems in a manner that prevents unauthorized access or data breaches. An incorrect approach that focuses solely on performance metrics without considering security or compliance would be professionally unacceptable. This failure constitutes a significant regulatory and ethical lapse. For instance, if the proposed change, while boosting performance, inadvertently opens a new attack vector or weakens access controls, it directly violates security best practices and potentially specific regulatory requirements, e.g., NIST SB 800-53 controls related to access control and system integrity. Similarly, an approach that bypasses stakeholder consultation or documentation risks creating an unmanageable situation, making it difficult to audit changes or respond effectively to incidents, which is a common failing in regulatory audits. Another incorrect approach might be to implement the change without a clear rollback strategy. This is ethically irresponsible as it jeopardizes business continuity and could lead to prolonged service disruption if the change proves detrimental, violating the professional duty to minimize harm. The professional decision-making process for similar situations should involve a structured risk assessment framework. This begins with clearly defining the scope of the proposed change and identifying all potential impacts across technical, security, compliance, and business domains. Engaging relevant stakeholders early in the process is crucial for gathering diverse perspectives and ensuring buy-in. Thorough documentation of the assessment, proposed changes, and mitigation strategies is essential for auditability and knowledge transfer. Finally, establishing clear go/no-go criteria and a robust rollback plan ensures that the organization can revert to a stable state if the change introduces unforeseen issues, thereby upholding professional responsibility and regulatory adherence. Question 8. The performance metrics show a significant improvement in application response times and overall network utilization after the implementation of a new Cisco SDWAN solution. However, a review of the data flow reveals that certain sensitive customer data is now being routed through new, potentially less scrutinized, internet egress points. Considering the enterprise operates under strict data privacy regulations, what is the most appropriate next step to ensure compliance and security? Option A. Initiate a broad security audit of the entire network infrastructure to identify any potential vulnerabilities, without specifically focusing on the new SDWAN data paths. Option B. Immediately revert the SDWAN configuration to the previous state to avoid any potential compliance issues, and then reevaluate the solution at a later time. Option C. Assume that the existing security policies are sufficient to protect the data, as the SDWAN solution is a Cisco-approved product, and proceed with full deployment. Option D. Conduct a detailed impact assessment of the new data routing paths on existing security controls and regulatory compliance, specifically verifying encryption, access controls, and logging for sensitive data. The correct answer is D. Conduct a detailed impact assessment of the new data routing paths on existing security controls and regulatory compliance, specifically verifying encryption, access controls, and logging for sensitive data. Explanation. This scenario presents a common challenge in enterprise network deployments: the need to balance the benefits of new technologies like Cisco SDWAN with the potential impact on existing security postures and compliance requirements. The professional challenge lies in conducting a thorough impact assessment that considers not just technical performance, but also the regulatory landscape governing data handling and network security. A hasty or incomplete assessment could lead to non-compliance, security vulnerabilities, and operational disruptions. The correct approach involves a systematic evaluation of how the proposed SDWAN implementation will affect data flow, access controls, and logging mechanisms, specifically in relation to the regulatory framework applicable to the enterprise's operations. This includes identifying any new data transit points, changes in encryption requirements, and the need for updated security policies and monitoring. By proactively identifying and mitigating potential compliance gaps before deployment, the organization upholds its legal and ethical obligations to protect sensitive data and maintain a secure network environment. This aligns with the principles of responsible technology adoption and risk management. An incorrect approach that focuses solely on network throughput and latency, without considering security implications, would fail to address potential regulatory violations. For instance, if the SDWAN solution inadvertently exposes sensitive data to unauthorized access or fails to meet data residency requirements mandated by regulations, it would constitute a significant ethical and legal breach. Another incorrect approach might involve assuming existing security controls are sufficient without verifying their compatibility with the new SDWAN architecture. This oversight could lead to a false sense of security and leave the network vulnerable to threats, violating the duty of care to protect the organization's assets and data. A third incorrect approach could be to defer security and compliance considerations to a later stage, which is inherently risky and unprofessional, as it prioritizes speed over due diligence and could result in costly remediation efforts or even regulatory penalties. Professionals should employ a structured decision-making process that begins with understanding the specific regulatory requirements relevant to the enterprise's industry and geographic location. This should be followed by a comprehensive risk assessment that maps the proposed SDWAN features and functionalities against these requirements. Key considerations include data privacy, data integrity, access control, auditability, and incident response capabilities. The assessment should involve collaboration with security, compliance, and legal teams to ensure all perspectives are considered. Finally, mitigation strategies should be developed and implemented to address any identified risks and ensure full compliance before and during the deployment of the SDWAN solution. Question 9. Analysis of the potential impact of implementing Cisco SDWAN on an enterprise network's existing security posture and operational workflows. A system engineer is tasked with developing a strategy to ensure a secure and compliant deployment. Which of the following approaches best addresses the need for a comprehensive impact assessment prior to full implementation? Option A. Conduct a thorough review of the SDWAN solution's technical specifications and vendor-provided best practices, then proceed with a phased deployment, addressing any security or operational issues as they arise. Option B. Engage key stakeholders from security, operations, and compliance teams to collaboratively identify potential risks, assess their impact on existing controls and workflows, and develop mitigation strategies before finalizing the deployment plan. Option C. Rely on the existing security policies and configurations to govern the SDWAN traffic, assuming that current controls are sufficient to manage any new security implications introduced by the technology. Option D. Prioritize the technical performance benefits of SDWAN, such as improved application routing, and defer detailed security and access control impact analysis until after the initial deployment is complete. The correct answer is A. Conduct a thorough review of the SDWAN solution's technical specifications and vendor-provided best practices, then proceed with a phased deployment, addressing any security or operational issues as they arise. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network deployments, balancing the need for rapid implementation of new technologies like Cisco SDWAN with the imperative to thoroughly assess their potential impact on existing security postures and operational workflows. The professional challenge lies in the inherent tension between speed and due diligence. A rushed deployment without a comprehensive impact assessment risks introducing unforeseen vulnerabilities, disrupting critical business operations, or failing to meet compliance requirements. Conversely, an overly cautious approach can delay critical business initiatives and lead to competitive disadvantages. The system engineer must navigate this by employing a structured, risk-based methodology. Correct approach analysis. The correct approach involves a proactive and systematic impact assessment that integrates security and operational considerations from the outset. This aligns with best practices in network engineering and cybersecurity emphasizing a security by design philosophy. By identifying potential impacts on data confidentiality, integrity, and availability, as well as on user access, application performance, and existing security controls, like ISE policies, the engineer can anticipate and mitigate risks. This approach ensures that the SDWAN deployment is not only functional, but also secure and compliant with relevant regulations and organizational policies. It fosters a collaborative environment where security and operations teams can work together to define requirements and validate outcomes, leading to a more robust and resilient network. This aligns with the principles of responsible technology adoption, where potential consequences are thoroughly evaluated before implementation. Incorrect approaches analysis. One incorrect approach is to proceed with the SDWAN deployment based solely on vendor documentation and initial configuration guides, without conducting a specific impact assessment tailored to the organization's unique environment. This represents a significant regulatory and ethical failure because it bypasses due diligence. It risks non-compliance with data protection regulations, e.g., GDPR if applicable, or similar frameworks governing data handling, by potentially exposing sensitive data or creating unauthorized access pathways. Ethically, it demonstrates a disregard for the potential harm to the organization and its stakeholders due to security breaches or operational disruptions. Another incorrect approach is to defer all security and impact considerations to the security operations team after the SDWAN infrastructure is already in place. This is a failure of proactive risk management and violates the principle of shared responsibility in cybersecurity. It creates a reactive security posture, making it more difficult and costly to remediate issues. From a regulatory standpoint, this can lead to non-compliance if security controls are not adequately integrated from the start, potentially violating requirements for risk assessment and mitigation. Ethically, it places an undue burden on the security team and increases the likelihood of security gaps going unnoticed. A third incorrect approach is to focus exclusively on the technical performance benefits of SDWAN, such as improved application routing and bandwidth optimization, while neglecting its implications for network segmentation and access control. This oversight can lead to the erosion of existing security boundaries, potentially allowing lateral movement of threats within the network. This is a critical failure in maintaining the principle of least privilege and defense in depth, which are fundamental to most cybersecurity frameworks and regulatory mandates. Ethically, it prioritizes efficiency over security, potentially exposing the organization to significant risks. Professional reasoning. Professionals should adopt a structured impact assessment framework that begins with defining the scope of the SDWAN deployment and its intended business objectives. This should be followed by a thorough analysis of potential impacts across security, operations, and compliance domains. Key steps include: 1. Stakeholder identification and engagement. Involve IT security, network operations, application owners, and compliance officers early in the process. 2. Risk identification. Brainstorm potential threats and vulnerabilities introduced by SDWAN, considering data flow, access control, and policy enforcement. 3. Impact analysis. Quantify the potential consequences of identified risks on business operations, data integrity, confidentiality, and availability. 4. Mitigation strategy development. Define controls and adjustments to existing policies and configurations to address identified risks. 5. Validation and testing. Conduct rigorous testing in a lab environment and phased rollout to confirm that mitigation strategies are effective and that the SDWAN solution meets security and operational requirements. 6. Documentation and continuous monitoring. Maintain detailed records of the assessment and establish ongoing monitoring to detect and respond to emerging risks. This systematic approach ensures that technology adoption is aligned with organizational risk tolerance and regulatory obligations, fostering a culture of security and operational excellence. Question 10. Market research demonstrates that Cisco's software-defined access, SDA, offers significant advancements in network segmentation and policy enforcement. An organization is considering a rapid deployment of SDA to address immediate compliance concerns and improve operational efficiency. What is the most prudent approach to ensure a successful and compliant implementation? Option A. Proceed with a direct implementation based on a vendor demonstration, prioritizing speed to meet compliance deadlines and leverage perceived operational efficiencies. Option B. Conduct a comprehensive impact assessment that evaluates technical, operational, and security implications involving key stakeholders and aligns with the organization's strategic IT goals and regulatory obligations. Option C. Deploy Cisco SDA immediately to address compliance concerns, deferring any detailed operational impact analysis until after the initial rollout is complete. Option D. Prioritize the cost-saving aspects of Cisco SDA, implementing it with minimal disruption to existing processes, and address any unforeseen technical or security issues as they arise. The correct answer is B. Conduct a comprehensive impact assessment that evaluates technical, operational, and security implications involving key stakeholders and aligns with the organization's strategic IT goals and regulatory obligations. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the immediate need for enhanced security and network segmentation with the long-term implications of technology adoption. The pressure to quickly implement a solution for compliance and operational efficiency without a thorough impact assessment can lead to unforeseen technical debt, integration issues, and potential security vulnerabilities. The professional challenge lies in advocating for a structured, risk-aware approach in the face of urgency, ensuring that the chosen solution aligns with both current requirements and future scalability, while adhering to relevant regulatory frameworks. Correct approach analysis. The correct approach involves a comprehensive impact assessment that considers the technical, operational, and security implications of adopting Cisco SDA. This assessment should involve stakeholders from IT operations, security, and business units to identify potential conflicts with existing infrastructure, applications, and workflows. It should also evaluate the learning curve for the IT team, the necessary changes to operational procedures, and the alignment with the organization's overall IT strategy and compliance mandates. This methodical approach ensures that the implementation is well planned, minimizes disruption, and maximizes the return on investment, while also proactively addressing potential risks and ensuring adherence to relevant cybersecurity best practices and any applicable data privacy regulations. Incorrect approach is analysis. Implementing Cisco SDA solely based on a vendor demonstration without a thorough internal assessment risks overlooking critical integration challenges with existing network devices, security policies, and application dependencies. This can lead to unexpected downtime, performance degradation, and the creation of new security gaps, potentially violating the principle of due diligence required by many regulatory frameworks concerning the security of information systems. Adopting Cisco SDA without considering the operational impact on the IT team's skill set and existing support processes can result in a poorly managed deployment. This can lead to extended troubleshooting times, increased operational costs, and a failure to fully leverage the capabilities of the technology, indirectly impacting the organization's ability to maintain a secure and compliant network environment. Focusing only on the cost savings of Cisco SDA without a corresponding assessment of its technical and security implications is a significant oversight. While cost is a factor, it should not supersede the fundamental requirements of network stability, security, and compliance. Neglecting these aspects can expose the organization to greater financial and reputational risks in the long run, potentially leading to non-compliance with data protection laws and industry standards. Professional reasoning. Professionals should adopt a phased approach to technology adoption, beginning with a thorough discovery and assessment phase. This involves understanding the current state, defining clear objectives, and identifying potential risks and dependencies. A structured impact assessment, involving cross-functional teams, is crucial for evaluating different solution options against these objectives and risks. This process should be guided by established IT governance frameworks and cybersecurity best practices, ensuring that decisions are data-driven, risk-informed, and aligned with regulatory requirements. The goal is to achieve a balance between innovation, operational efficiency, and robust security. Question 11. Process analysis reveals that a large enterprise is planning a significant Cisco SDWAN deployment across multiple international sites. The primary drivers are improved network performance and reduced operational costs. However, the organization handles sensitive customer data, including personally identifiable information, PI, and financial transaction details, and operates under various data protection regulations. Which approach to assessing the impact of this SDWAN deployment best ensures regulatory compliance and mitigates legal risks? Option A. Focus the impact assessment solely on the technical performance improvements and cost savings offered by SDWAN, deferring any detailed regulatory compliance review until after the network is fully operational. Option B. Delegate the entire responsibility for assessing regulatory compliance related to the SDWAN deployment to the network engineering team, trusting their technical expertise to interpret and apply relevant legal obligations. Option C. Proceed with the SDWAN deployment based on the assumption that existing enterprise-wide security policies and controls are sufficient to meet all regulatory requirements for the new network architecture. Option D. Conduct a comprehensive impact assessment that specifically identifies all applicable data protection regulations, e.g., GDPR, CCPA, or equivalent national laws, and evaluates how the SDWAN architecture, including traffic routing, encryption, and access control mechanisms, will affect compliance with these mandates, integrating findings into the design and implementation phases. The correct answer is D. Conduct a comprehensive impact assessment that specifically identifies all applicable data protection regulations, e.g., GDPR, CCPA, or equivalent national laws, and evaluates how the SDWAN architecture, including traffic routing, encryption, and access control mechanisms, will affect compliance with these mandates, integrating findings into the design and implementation phases. Explanation. Scenario analysis. The scenario presents a common challenge in enterprise network deployments, integrating new technologies like Cisco SDWAN while ensuring compliance with evolving security and data privacy regulations. The professional challenge lies in balancing the immediate benefits of SDWAN agility, cost savings, with the imperative to maintain a robust security posture and adhere to regulatory mandates, particularly concerning data handling and network access. The complexity arises from the distributed nature of SDWAN, the potential for increased attack surfaces, and the need for granular visibility and control over traffic flows, all of which must be assessed against a backdrop of strict compliance requirements. Correct approach analysis. The correct approach involves a proactive and comprehensive impact assessment that integrates regulatory compliance from the outset. This means identifying all relevant regulations, e.g., GDPR if dealing with EU citizen data, HIPAA if in healthcare, PCI DSS for payment card data, or specific national data protection laws relevant to the exam's jurisdiction that apply to the data traversing the SDWAN network. The assessment must then evaluate how the proposed SDWAN implementation will affect compliance with these regulations, focusing on aspects like data encryption, access controls, logging, auditing, and data residency. This approach ensures that security and compliance are not afterthoughts, but are embedded into the design and deployment process, minimizing the risk of non-compliance, potential fines, and reputational damage. It aligns with the principle of privacy by design and security by design, which are fundamental to modern regulatory frameworks. Incorrect approaches analysis. One incorrect approach is to prioritize solely the technical benefits and cost savings of SDWAN without a thorough regulatory impact assessment. This failure to consider compliance can lead to significant regulatory violations, especially if sensitive data is mishandled or if access controls are insufficient to meet legal requirements. For example, if the SDWAN solution inadvertently exposes personal data to unauthorized access or fails to meet data localization requirements, it could result in severe penalties under data protection laws. Another incorrect approach is to assume that existing security measures are sufficient for the SDWAN environment without a specific assessment. SDWAN introduces new traffic patterns and control planes that may bypass or circumvent traditional security perimeters. Without a targeted impact assessment, critical vulnerabilities could be overlooked, leading to breaches that violate regulatory obligations regarding data security and integrity. A third incorrect approach is to delegate the entire compliance responsibility to the IT operations team without involving legal or compliance officers. While IT operations manages the network, they may lack the specialized knowledge of legal and regulatory nuances. This can result in misinterpretations of compliance requirements, leading to a deployment that appears technically sound but is legally non-compliant, exposing the organization to significant risks. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment for SDWAN deployments. This involves 1. Identifying all applicable regulatory frameworks based on the organization's industry, geographic location, and the type of data processed. 2. Conducting a thorough analysis of how the SDWAN solution will interact with and potentially impact compliance with these regulations across all layers of the network and data flow. 3. Engaging stakeholders from IT, security, legal, and compliance departments early in the planning process. 4. Developing and implementing mitigation strategies to address any identified compliance gaps before deployment. 5. Establishing ongoing monitoring and auditing processes to ensure continued compliance post-implementation. Question 12. Research into the deployment of Cisco SDWAN solutions within a large enterprise network has revealed a critical need to understand the potential ramifications of integrating this new technology. Given the complexity of the existing infrastructure and the sensitive nature of the data traversing the network, what is the most prudent approach to ensure a successful and compliant implementation? Option A. Prioritize the immediate deployment of the SDWAN solution to leverage its perceived benefits quickly, with a plan to address any unforeseen issues through post-implementation troubleshooting and configuration adjustments. Option B. Proceed with a phased rollout of the SDWAN solution, closely monitoring network performance and security logs for any anomalies, and addressing issues as they arise. Option C. Conduct a comprehensive impact assessment that meticulously analyzes the technical, operational, security, and business implications of the SDWAN deployment, including potential conflicts with existing policies and regulatory requirements, before initiating any implementation. Option D. Delegate the responsibility of impact assessment to the vendor providing the SDWAN solution, trusting their expertise to identify and mitigate all potential risks without direct internal oversight. Correct answer is B. Proceed with a phased rollout of the SDWAN solution, closely monitoring network performance and security logs for any anomalies, and addressing issues as they arise. Explanation. The scenario presents a common challenge in enterprise network deployments, balancing the need for rapid implementation of new technologies like Cisco SDWAN with the imperative to conduct thorough impact assessments. The professional challenge lies in the potential for unforeseen consequences of network changes, which can range from service disruptions and performance degradation to security vulnerabilities and compliance breaches. A hasty deployment without a proper impact assessment risks significant business disruption and reputational damage. The correct approach, which involves a comprehensive impact assessment before implementing SDWAN, represents best professional practice because it aligns with the principles of responsible IT governance and risk management. Cisco's own best practices and the general principles of ITIL, Information Technology Infrastructure Library, emphasize the importance of change management and impact analysis. From a regulatory perspective, while the 500-470 exam focuses on technical aspects, the underlying principle of ensuring network stability and security is paramount. A robust impact assessment helps identify potential conflicts with existing security policies, data privacy requirements, e.g., GDPR if applicable to the enterprise's operations. Though the exam is jurisdiction agnostic in its core technical content, the implications of network changes can touch upon compliance and business continuity plans. It ensures that the new technology is integrated in a way that minimizes risk and maximizes benefit, adhering to the implicit expectation of reliable and secure network services. An incorrect approach that bypasses or inadequately performs an impact assessment is professionally unacceptable due to several regulatory and ethical failures. Firstly, it demonstrates a disregard for due diligence, a fundamental ethical obligation for IT professionals. This can lead to direct financial losses for the organization due to downtime or data breaches. Secondly, it potentially violates internal IT policies and procedures designed to govern change management, which are often established to meet external regulatory compliance requirements, e.g., SOX for financial reporting, BA for healthcare data. Even if not explicitly tested, the principles of secure data handling are universal. For instance, If the SDWAN implementation inadvertently exposes sensitive data due to misconfiguration, the organization could face significant fines and legal repercussions. Furthermore, it erodes trust between the IT department and business stakeholders, as it suggests a lack of professionalism and foresight. The professional decision-making process for similar situations should involve a structured approach to change management. This begins with clearly defining the scope and objectives of the proposed change. Next, a detailed impact assessment should be conducted, considering technical, operational, security, and business implications. This involves identifying all affected systems, applications, and users, and evaluating potential risks and benefits. Stakeholder consultation is crucial throughout this process. Based on the assessment, a mitigation plan for identified risks should be developed. Finally, a formal change request and approval process should be followed before implementation, with rollback plans in place. This systematic approach ensures that changes are implemented responsibly, minimizing disruption and maximizing the likelihood of success. Question 13. Quality control measures reveal that a significant number of new Internet of Things (IoT) devices have been deployed across the enterprise network without a defined security segmentation strategy, potentially exposing sensitive internal resources. The current network infrastructure utilizes Cisco SDA principles. What is the most appropriate and secure approach to segment these newly deployed IoT devices to mitigate potential risks? Option A. Dynamically assign IoT devices to specific virtual networks, VN, based on their identity and security profile, enforced by Cisco ISE policies within the SDA fabric. Option B. Create a dedicated, isolated subnet for all IoT devices and allow unrestricted communication within this subnet and to all other internal network segments. Option C. Place all newly deployed IoT devices into a single, broad VLAN with basic firewall rules at the network perimeter to restrict external access. Option D. Manually configure access control lists, ACL, on core network switches to restrict traffic flow between IoT devices and other network segments. The correct answer is A. Dynamically assign IoT devices to specific virtual networks, VN, based on their identity and security profile, enforced by Cisco ISE policies within the SDA fabric. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network deployments where security and network segmentation are paramount. The challenge lies in balancing the need for efficient network access for legitimate users and devices with the imperative to prevent unauthorized access and potential lateral movement of threats. The introduction of new IoT devices, often with less robust security postures, exacerbates this challenge. A misconfiguration in network segmentation can lead to significant security vulnerabilities, data breaches, and compliance failures. The professional challenge is to implement a robust segmentation strategy that is both effective and manageable, adhering to Cisco's SDA principles and relevant security best practices without compromising operational efficiency. Correct approach analysis. Implementing granular network segmentation using Cisco SDA policies, specifically leveraging TrustSec and Identity Services Engine (ISE) for policy enforcement, represents best professional practice. This approach aligns directly with the principles of software-defined access (SDA), which aims to simplify network management and enhance security through policy-driven automation. ISE's ability to authenticate and authorize users and devices based on their identity and context allows for dynamic assignment to specific network segments, VN. This ensures that IoT devices, once authenticated and profiled, are placed in a segment with the minimum necessary privileges and access controls, thereby limiting their potential impact if compromised. This adheres to the principle of least privilege, a fundamental security tenet. Incorrect approach is analysis. Placing all new IoT devices into a single, broad VLAN without specific access controls is a significant regulatory and ethical failure. This approach violates the principle of least privilege, creating a flat network where a compromised IoT device could easily access sensitive corporate resources. It also fails to meet the security requirements expected in modern enterprise networks, potentially leading to noncompliance with data protection regulations if sensitive data resides on accessible segments. Implementing a basic firewall rule at the perimeter to block external access to the IoT segment, while seemingly a security measure, is insufficient. This approach ignores the internal threat landscape and the risk of lateral movement. If an EOT device is compromised internally, it could still pose a threat to other internal systems. This lack of internal segmentation is a critical security gap and a failure to implement defense in depth. Manually configuring access control lists, ACL, on individual network devices for each EOT device or group of devices is inefficient and prone to errors. While it attempts to provide some level of segmentation, it is not scalable and does not leverage the automated policy enforcement capabilities of SDA. This manual approach increases the risk of misconfiguration, leading to security gaps or operational disruptions, and fails to meet the dynamic policy requirements of a modern, evolving network. Professional reasoning. Professionals should approach this situation by first understanding the specific security requirements and compliance obligations related to EOT devices within the organization. This involves identifying the data sensitivity of connected EOT devices and the potential impact of their compromise. Next, they should leverage the capabilities of Cisco SDA and ISE to define granular security policies based on device identity, user context, and location. This policy-driven approach ensures that segmentation is dynamic, enforceable, and auditable. Regular review and updates of these policies are crucial to adapt to new threats and evolving business needs. Question 14. The assessment process reveals that a financial services firm is implementing Cisco SDA to enhance network agility and automate policy enforcement. However, the firm handles highly sensitive customer financial data, which is subject to strict data privacy regulations, requiring granular access control and isolation of this data from other network segments. The firm's current security policies are documented but not explicitly mapped to the capabilities of SDA. The IT team is considering several approaches to integrate SDA with their compliance obligations. Which of the following approaches best ensures that the SDA implementation adheres to the firm's regulatory obligations for data privacy and access control? Option A. Configure SDA to create broad network segments based on department and rely on existing firewall rules at the network perimeter for data protection. Option B. Develop specific security groups within SDA that directly correspond to data sensitivity levels and regulatory access requirements, and apply granular policies to control traffic flow between these groups. Option C. Focus solely on the performance benefits of SDA and assume that its inherent network virtualization capabilities will automatically satisfy all data privacy regulations without explicit policy mapping. Option D. Deploy SDA with default segmentation policies and plan to address specific regulatory requirements through ad hoc manual configurations as compliance audits are scheduled. Correct answer is A. Configure SDA to create broad network segments based on department and rely on existing firewall rules at the network perimeter for data protection. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design where the implementation of a new technology, software-defined access, SDA, must align with existing security policies and regulatory compliance. The challenge lies in balancing the agility and automation offered by SDA with the stringent requirements for data privacy and network segmentation mandated by regulations. A misstep in configuration or policy enforcement can lead to significant security vulnerabilities, data breaches, and non-compliance penalties, impacting the organization's reputation and financial stability. The need for a thorough understanding of both SDA's capabilities and the relevant regulatory landscape is paramount. Correct approach analysis. The correct approach involves leveraging SDA's policy-driven segmentation capabilities to enforce granular access controls that directly map to regulatory requirements. This means defining security groups and policies within SDA that reflect the data classification and access restrictions dictated by the relevant regulatory framework. For instance, if a regulation mandates that sensitive customer data must be isolated and access restricted to authorized personnel only, SDA can be configured to place devices handling this data into a specific security group, with policies that only permit communication with other authorized groups. This approach ensures that the network architecture inherently supports compliance by design, making it easier to audit and maintain adherence to regulations. It aligns with the principle of least privilege and defense in depth, which are fundamental to robust security and regulatory compliance. Incorrect approaches analysis. Implementing SDA without a clear mapping of its segmentation features to regulatory data handling requirements is a significant failure. This could manifest as broad, non-specific segmentation that doesn't adequately isolate sensitive data, or worse, allowing unrestricted communication between segments that should be isolated. This directly violates the spirit and letter of regulations requiring data protection and access control. Another failure would be to rely solely on traditional perimeter security devices after deploying SDA, neglecting to integrate SDA's internal segmentation policies with regulatory mandates. This creates a false sense of security, as internal threats or compromised devices within less restricted segments could still access sensitive data. Furthermore, failing to document and audit the SDA policies against regulatory requirements means there's no verifiable proof of compliance, which is often a key audit finding. Professional reasoning. Professionals must adopt a compliance-first mindset when designing and implementing network solutions like SDA. This involves proactively identifying all applicable regulatory requirements related to data handling, privacy, and access control. The next step is to translate these requirements into specific network security policies. Then, the capabilities of the chosen technology, in this case SDA, should be evaluated to determine how best to implement these policies. This often involves a detailed mapping exercise between regulatory mandates and SDA's features such as security groups, policy enforcement nodes, and identity services. Regular audits and continuous monitoring are crucial to ensure ongoing compliance. This systematic approach ensures that technology adoption enhances, rather than compromises, the organization's security posture and regulatory standing. Question 15. Which approach would be most effective in deploying Cisco ISE for network access control in a large enterprise with a diverse range of endpoints and user roles, aiming to enhance security posture while minimizing operational disruption? Option A. Implement a comprehensive set of strict access control policies immediately upon deployment, covering all user roles and endpoint types, with a plan to address any access issues reactively. Option B. Focus on deploying the most technically advanced security features first, such as advanced threat detection and granular segmentation, before addressing basic access control policies. Option C. Utilize pre-built security templates from Cisco's documentation without significant customization, assuming they will adequately address the enterprise's specific security needs. Option D. Begin by deploying ISE in a monitoring-only mode to profile endpoints and users, gradually introducing profiling-based policies, and then moving to enforcement for critical resources, followed by broader policy application. The correct answer is A. Implement a comprehensive set of strict access control policies immediately upon deployment, covering all user roles and endpoint types, with a plan to address any access issues reactively. Explanation. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational demands of a dynamic and evolving business environment. The core difficulty lies in ensuring that security policies, particularly those enforced by Cisco ISE, remain effective and compliant without hindering legitimate user access or introducing unnecessary complexity. The regulatory framework for this exam, Cisco Enterprise Networks SDA, SDWAN, and ISE, implies adherence to general IT best practices and Cisco's recommended security postures, rather than specific external legal statutes. The correct approach prioritizes a phased, risk-based implementation of ISE policies, starting with monitoring and profiling before enforcing strict access controls. This aligns with best professional practice by minimizing disruption, allowing for validation of policy effectiveness, and ensuring that security measures are proportionate to identified risks. It allows for iterative refinement based on real-world network behavior, a crucial aspect of maintaining a secure and functional enterprise network. An incorrect approach that immediately enforces stringent policies without prior analysis risks locking out legitimate users, disrupting critical business operations, and generating a high volume of support tickets. This demonstrates a failure to adequately plan and test, leading to operational inefficiencies and potentially undermining user trust in the security infrastructure. Another incorrect approach, focusing solely on technical implementation without considering user impact or business needs, neglects the human element of network security and can lead to policies that are technically sound but practically unworkable. A third incorrect approach, relying on outdated or generic security templates without customization, fails to address the specific vulnerabilities and requirements of the enterprise network, leaving it exposed to threats and potentially violating the principle of due diligence in security management. Professionals should approach such situations by first understanding the business requirements and existing network landscape. This involves a thorough risk assessment, followed by a phased deployment strategy that includes monitoring, profiling, and gradual policy enforcement. Continuous evaluation and adaptation of policies based on network telemetry and user feedback are essential for maintaining an effective and compliant security posture. Question 16. The review process indicates that a significant number of new EOT devices are being onboarded to the enterprise network using Cisco SDA, and the current ISE policy for these devices has not been updated in over a year. The system engineering team is proposing to implement a new, more restrictive ISE policy for these devices to enhance security. Which of the following approaches best aligns with secure and compliant network operations for this scenario? Option A. Rely on the existing ISE policy, assuming it is still adequate, and only consider updates if a security incident directly related to EOT devices occurs. Option B. Deploy the new ISE policy with minimal testing, assuming that the vendor's recommended security settings are sufficient for the enterprise environment. Option C. Implement the new ISE policy for a pilot group of EOT devices, thoroughly test access and functionality, and then incrementally roll out the policy to the rest of the devices based on successful pilot results. Option D. Immediately deploy the new, more restrictive ISE policy to all new EOT devices as they are onboarded, and address any access issues reported by users after the fact. The correct answer is D. Immediately deploy the new, more restrictive ISE policy to all new EOT devices as they are onboarded, and address any access issues reported by users after the fact. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational demands of a dynamic environment. The core difficulty lies in ensuring that security policies, particularly those enforced by ISE for network access control, remain effective and compliant without hindering legitimate user access or introducing excessive administrative overhead. The rapid onboarding of new devices and the potential for misconfigurations or policy drift necessitate a proactive and well-defined review process. The challenge is amplified by the need to adhere to specific Cisco SDA and SDWAN best practices, which often involve automated policy enforcement and integration with broader security frameworks. Correct approach analysis. The correct approach involves a systematic and documented process for reviewing and updating ISE policies in conjunction with network device onboarding. This aligns with the principles of secure network lifecycle management and the operational best practices for Cisco SDWAN and SDA. Specifically, it emphasizes the importance of pre-deployment validation of policies against the specific device type and its intended role, ensuring that the principle of least privilege is maintained. Regular audits and automated checks, as facilitated by ISE and its integration with network controllers, are crucial for identifying and rectifying policy deviations before they can be exploited. This proactive stance minimizes the attack surface and ensures ongoing compliance with security mandates, which is a cornerstone of responsible system engineering. Incorrect approach is analysis. Implementing a new policy without a thorough pre-deployment validation process is a significant regulatory and ethical failure. It bypasses critical security checks, potentially allowing unauthorized access or misconfigured devices onto the network, violating the principle of secure by design. This approach increases the risk of security breaches and non-compliance with internal security standards and potentially external regulations if sensitive data is involved. Adopting a set it and forget it mentality for ISE policies, relying solely on post-deployment monitoring for anomalies, is also professionally unacceptable. This reactive approach is inherently less secure, as it allows vulnerabilities to exist for an extended period before detection. It fails to uphold the duty of care to protect the network and its data, and it contradicts the proactive security posture expected in modern enterprise environments, especially those leveraging SDA and SDWAN for dynamic policy enforcement. Relying solely on vendor default configurations without customization for the specific enterprise environment is a critical oversight. Default configurations are often generic and may not align with the organization's unique security requirements, risk appetite, or compliance obligations. This can lead to overpermissive access controls or insufficient security measures, creating significant security gaps and potential compliance issues. Professional reasoning. Professionals should adopt a risk-based lifecycle approach to network security. This involves 1. Understanding the organization's security policies, compliance requirements, and threat landscape. 2. Designing and implementing security controls, like ISE policies, with a focus on least privilege and defense in depth. 3. Establishing robust change management processes that include thorough testing and validation of all network and security configurations before deployment. 4. Implementing continuous monitoring and regular auditing to detect and respond to security incidents and policy drift. 5. Maintaining comprehensive documentation of all security configurations, policies, and review processes. This systematic approach ensures that security remains an integral part of network operations, rather than an afterthought, and fosters a culture of continuous improvement and accountability. Question 17. The analysis reveals that a financial services firm is migrating its branch offices to a Cisco SDWAN solution to improve application performance and agility. During the design phase, the engineering team is debating the most effective method for ensuring that sensitive customer financial data, which will traverse the SDWAN, remains protected and compliant with U.S. federal regulations such as the Gramm-Leach-Bliley Act, GLBA. The firm needs a solution that provides granular access control, enforces security policies dynamically, and offers auditable logs for compliance reporting. Which approach best addresses these requirements while adhering to the principles of modern network security and regulatory mandates? Option A. Implement SDWAN with basic ISE VPN tunnels between all sites and rely on individual branch firewalls for access control, assuming all traffic is inherently trusted once it enters the VPN. Option B. Deploy Cisco SDWAN with a centralized Cisco ISE deployment integrated for identity-based access control, dynamic policy assignment, and comprehensive logging of user and device access to network resources. Option C. Configure SDWAN to prioritize traffic based on application type and use network segmentation solely at the data center, without specific identity-based controls at the branch edge. Option D. Utilize SDWAN's built-in encryption features and assume that the inherent security of the SDWAN fabric is sufficient to meet GLBA requirements without additional access control mechanisms. The correct answer is A. Implement SDWAN with basic ISE VPN tunnels between all sites and rely on individual branch firewalls for access control, assuming all traffic is inherently trusted once it enters the VPN. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security and compliance with the operational demands of a dynamic business environment. The core difficulty lies in ensuring that the implementation of Cisco SDWAN, a technology designed for agility and efficiency, does not inadvertently create security vulnerabilities or compliance gaps, particularly concerning data privacy regulations. The system engineer must navigate the complexities of policy enforcement across a distributed network while adhering to the specific requirements of the exam's jurisdiction, which for this context is assumed to be the United States, focusing on relevant federal regulations. Correct approach analysis. The correct approach involves a proactive and integrated security strategy that leverages Cisco ISE for granular access control and policy enforcement within the SDWAN fabric. This aligns with best practices for zero-trust architectures and regulatory frameworks like HIPAA, Health Insurance Portability and Accountability Act, and PCI DSS, Payment Card Industry Data Security Standard, which mandate strong access controls and data protection for sensitive information. By using ISE to authenticate and authorize users and devices before granting access to network resources, and by dynamically assigning security policies based on context, user identity, device posture, location, the organization ensures that only authorized entities can access specific data segments. This approach directly addresses the need for compliance by providing auditable logs of access and enforcing policies consistently across the SDWAN edge. Incorrect approaches analysis. Implementing SDWAN without a robust, integrated access control solution like ISE introduces significant regulatory and ethical risks. Relying solely on perimeter security or basic firewall rules at the WAN edge is insufficient in a zero-trust model and fails to meet the granular access control requirements of many U.S. regulations. This approach would likely lead to unauthorized access to sensitive data, a direct violation of data privacy laws. Another incorrect approach would be to deploy SDWAN with a fragmented security model, where different security policies are managed independently across various network segments or branches. This lack of centralized policy management creates inconsistencies, increases the likelihood of misconfigurations, and makes auditing for compliance extremely difficult. Such fragmentation could lead to breaches of data confidentiality and integrity, violating regulations that require consistent security controls. A third incorrect approach would be to prioritize network performance and agility over security and compliance during the SDWAN deployment. While SDWAN is chosen for its performance benefits, neglecting the security implications of its implementation can lead to significant compliance failures. For instance, if sensitive patient data, under HIPAA, or payment card information, under PCI DSS, is transmitted across the SDWAN without adequate encryption or access controls enforced by a solution like ISE, it constitutes a serious breach of regulatory requirements and ethical obligations to protect sensitive information. Professional reasoning. Professionals must adopt a security-first mindset when designing and implementing SDWAN solutions. This involves understanding the specific regulatory landscape of their operating jurisdiction and integrating security controls from the outset. A systematic approach includes 1. Risk assessment. Identify sensitive data and critical assets that will traverse the SDWAN. 2. Regulatory mapping. Understand which U.S. federal regulations, e.g., HIPAA, PCI DSS, CMMC, apply to the data and operations. 3. Zero trust design. Architect the network based on the principle of never trust, always verify, using solutions like Cisco ISE for granular authentication and authorization. 4. Policy enforcement. Define and implement consistent security policies across the entire SDWAN fabric, leveraging centralized management tools. 5. Continuous monitoring and auditing. Establish mechanisms for ongoing security monitoring and regular audits to ensure compliance and detect anomalies. 6. Change management. Implement strict change control processes for any modifications to the SDWAN or security configurations. Question 18. Process analysis reveals that a critical business application requires a specific network path through the Cisco SDWAN fabric that deviates from the established security policy regarding allowed egress points. The system engineer has identified a workaround that meets the application's functional requirements, but bypasses a standard security inspection point. The organization has a formal change management process, but no explicit policy for security exceptions related to SDWAN configurations. The pressure to enable the application quickly is high. What is the most professionally responsible course of action? Option A. Escalate the issue to Cisco TAC for a recommendation on how to best configure the SDWAN to meet the application's needs without involving internal security teams. Option B. Obtain informal verbal approval from the direct line manager to implement the workaround, assuming they understand the business urgency. Option C. Implement the workaround immediately to meet the business deadline, and then retroactively document the change and seek approval. Option D. Document the deviation, assess the associated risks, and initiate a formal exception request through the established change management process, engaging security and compliance teams for review and approval. The correct answer is D. Document the deviation, assess the associated risks, and initiate a formal exception request through the established change management process, engaging security and compliance teams for review and approval. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network deployments where the rapid adoption of new technologies like Cisco SDWAN can outpace the formalization of security policies and compliance checks. The core challenge lies in balancing the business imperative for agility and connectivity with the absolute necessity of maintaining a secure and compliant network posture. The system engineer is caught between the pressure to deliver functional solutions quickly and the risk of introducing vulnerabilities or non-compliance by bypassing established security protocols. The lack of explicit documentation and a defined process for exceptions creates a gray area, increasing the potential for misjudgment and significant security or regulatory breaches. Correct approach analysis. The correct approach emphasizes adherence to established security policies and the formalization of any deviations. This aligns with best practices for enterprise network security and compliance, particularly within regulated industries. Cisco's own security frameworks and the principles of zero trust architecture, which are foundational to SDWAN and SDA deployments, mandate a policy-driven, least privilege access model. By requiring a documented exception process, the engineer ensures that any deviation from standard policy is reviewed, approved, and understood in terms of its risk. This process typically involves security teams, compliance officers, and relevant stakeholders, ensuring that the business need is weighed against potential security implications. This approach upholds the integrity of the security posture, facilitates auditing, and prevents the ad hoc introduction of risks. It is professionally sound because it prioritizes risk mitigation and accountability, which are paramount in system engineering roles. Incorrect approaches analysis. Implementing the change without any formal documentation or approval, despite knowing it deviates from policy, represents a significant regulatory and ethical failure. This bypasses established security controls and introduces unmanaged risk. It violates the principle of least privilege and can lead to unauthorized access or data breaches. From a compliance perspective, it demonstrates a disregard for internal controls and potentially external regulations that mandate secure network configurations and change management. Seeking informal approval from a direct manager without involving the security or compliance teams is also professionally unacceptable. While the manager might have authority, they may not possess the specialized knowledge to assess the security implications of the deviation. This approach outsources the risk assessment to an unqualified party, potentially leading to a decision that compromises security for expediency. It fails to engage the necessary expertise and can create a false sense of security. Escalating the issue directly to a vendor without first exhausting internal policy and approval channels is a premature and unprofessional step. While vendors can provide technical guidance, they are not responsible for the client's internal security policies or compliance obligations. This approach circumvents internal governance, potentially creating a conflict of interest and failing to leverage the organization's own established processes for risk management and decision-making. It suggests an unwillingness to navigate internal procedures and an abdication of responsibility. Professional reasoning. Professionals in system engineering roles must adopt a risk-based decision-making framework. When faced with a situation requiring a deviation from established policy, the process should always involve 1. Identifying the deviation and its potential impact. 2. Consulting relevant policies and documentation. 3. Engaging the appropriate stakeholders, including security, compliance, and business unit representatives. 4. Documenting the proposed change, the rationale, and the risk assessment. 5. Obtaining formal approval through a defined exception process. 6. Implementing the change with appropriate monitoring and validation. This structured approach ensures that decisions are informed, accountable, and aligned with the organization's overall security and compliance objectives. Question 19. Operational review demonstrates that a significant number of endpoints in the engineering department are intermittently failing posture assessment checks, leading to temporary network access disruptions for critical design tools. The security team is concerned about the potential for unpatched or non-compliant devices to gain access, while the engineering department is experiencing productivity losses due to these access issues. The current ISE policy grants full network access to all authenticated users and devices within the engineering VLAN, regardless of posture assessment results, as a temporary measure to mitigate productivity impact. What is the most appropriate course of action to address this situation while maintaining a strong security posture and minimizing operational impact? Option A. Disable posture assessment for all endpoints in the engineering department until a permanent solution for the intermittent failures can be identified and implemented. Option B. Immediately revert the ISE policy to grant full network access to all devices in the engineering VLAN without any posture assessment to eliminate productivity disruptions. Option C. Implement a tiered access policy in ISE that grants limited network access to non-compliant devices, allowing them to remediate their posture issues, while granting full access to compliant devices. Option D. Broadly expand network access privileges for all devices within the engineering VLAN to ensure no endpoint experiences further access disruptions. The correct answer is C. Implement a tiered access policy in ISE that grants limited network access to non-compliant devices, allowing them to remediate their posture issues, while granting full access to compliant devices. Explanation. This scenario presents a professional challenge in balancing network security posture with operational efficiency and compliance within the Cisco Enterprise Network's SDA, SDWAN, and ISE ecosystem. The core difficulty lies in interpreting and applying the principles of least privilege and granular access control, as mandated by security best practices and implied by the functionalities of ISE, without inadvertently disrupting critical business operations or creating security gaps. The need to ensure that only authorized devices and users can access specific network segments and resources is paramount. The correct approach represents best professional practice because it directly addresses the identified security concern by leveraging the granular policy enforcement capabilities of Cisco ISE. By defining specific access policies based on device posture, user identity, and network context, it ensures that only compliant and authorized entities gain access to sensitive resources. This aligns with the principle of least privilege, a fundamental security tenet, and supports the overall security strategy of an SDA/SDWAN deployment. Furthermore, it allows for dynamic policy adjustments, enhancing agility and responsiveness to evolving threats and business needs, which is crucial for maintaining a secure and functional enterprise network. An incorrect approach that involves broadly granting access to all devices or users without proper validation fails to uphold the principle of least privilege. This creates significant security vulnerabilities, potentially allowing unauthorized access to sensitive data and systems, which is a direct contravention of security best practices and could lead to regulatory non-compliance if data privacy or integrity is compromised. Another incorrect approach, such as disabling posture assessment entirely, bypasses a critical security control designed to ensure devices meet minimum security requirements before network access is granted. This exposes the network to malware, unpatched vulnerabilities, and other threats, representing a severe security lapse and a failure to implement robust security controls as expected in an enterprise environment. A third incorrect approach, focusing solely on user authentication without considering device posture, overlooks a significant attack vector. Compromised devices, even with authenticated users, can still pose a threat, demonstrating an incomplete security strategy. Professionals should approach such situations by first thoroughly understanding the business requirements and the criticality of the resources being protected. They should then analyze the security posture of the devices and users attempting to access these resources. The decision-making process should involve a risk assessment, evaluating the potential impact of granting or denying access. Leveraging the capabilities of security tools like Cisco ISE to implement context-aware, policy-driven access control based on the principle of least privilege should be the guiding framework. Regular review and refinement of policies are essential to adapt to changing threat landscapes and business needs. Question 20. During the evaluation of a persistent network performance issue impacting critical business applications within a Cisco SDWAN environment, a system engineer needs to capture and analyze network traffic to identify the root cause. Considering the need to comply with internal security policies and potential data privacy regulations, which of the following methods represents the most secure and compliant approach for obtaining the necessary traffic data? Option A. Request full administrative access to all end-user devices within the affected network segment to perform packet captures directly on their systems. Option B. Directly log into production routers and switches to initiate packet capture commands, saving the captured data to a local drive on the engineer's workstation for immediate analysis. Option C. Configure a span, switched port analyzer, session on a relevant switch or router to mirror traffic to a dedicated network analysis tool, ensuring the tool is configured for secure storage and access. Option D. Implement a broad network-wide packet capture across all network segments and store the raw data in a publicly accessible cloud storage bucket for easy access by the engineering team. The correct answer is C. Configure a span switched port analyzer session on a relevant switch or router to mirror traffic to a dedicated network analysis tool, ensuring the tool is configured for secure storage and access. Explanation: scenario analysis. This scenario presents a professional challenge in a regulated environment where network security and data privacy are paramount. The system engineer must balance the need for efficient network operation and troubleshooting with the strict requirements for data handling and access control. The challenge lies in identifying the most appropriate method for obtaining necessary network traffic data for analysis without violating established security policies or regulatory mandates, particularly concerning sensitive information that might be captured. Correct approach analysis. The correct approach involves utilizing a method that captures network traffic in a controlled and secure manner, adhering to the principle of least privilege and data minimization. This typically means employing network taps or span ports configured to mirror traffic to a dedicated analysis tool. The key is that this method allows for granular control over what traffic is captured and where it is sent, ensuring that sensitive data is not inadvertently exposed or stored insecurely. Furthermore, it aligns with best practices for network monitoring and troubleshooting, which are often implicitly or explicitly covered by general IT security frameworks and potentially specific regulations concerning data handling and privacy, depending on the industry and jurisdiction. For the 500-470 exam, this implies a focus on Cisco's recommended practices for network visibility within SDA and SDWAN, which prioritize secure and efficient data collection for troubleshooting and policy enforcement. Incorrect approaches analysis. An incorrect approach would be to directly access and analyze live traffic on production network devices without proper authorization or a defined process. This could involve logging into routers or switches and attempting to capture packets directly, which bypasses security controls and audit trails. Such an action would likely violate internal security policies regarding unauthorized access and could lead to the accidental exposure of sensitive data, creating a significant regulatory and ethical failure. It also increases the risk of disrupting network operations. Another incorrect approach would be to indiscriminately capture all network traffic and store it in an unsecured location. This violates data minimization principles and creates a substantial risk of data breach, which would have severe regulatory consequences, especially if the captured data contains personally identifiable information, PI, or other sensitive corporate data. This directly contravenes the spirit and letter of data protection regulations. Professional reasoning. Professionals should adopt a systematic approach to network troubleshooting and analysis. This involves first understanding the scope of the problem and the data required for diagnosis. Then, they must consult relevant internal security policies, compliance guidelines, and the specific documentation for the technologies in use, e.g., Cisco SDA, SD-WAN. The chosen method for data capture should always prioritize security, privacy, and compliance. This means using approved tools and techniques, obtaining necessary permission, and ensuring that data is handled and stored securely. In situations involving sensitive data, a risk assessment should be performed, and data anonymization or pseudonymization techniques should be considered if feasible and appropriate. The decision-making process should be documented to ensure accountability and facilitate future audits.